Hello students, so we are asked to explain why are curved road banked. So here we can see the diagram of two roads, one is a flat road and another is a banked road. So here at the flat road we can see that force of friction and centripetal force both are horizontal. In case of banked road, the force of friction is along the incline and the centripetal force is horizontal, right? Now, looking at the maximum permitted velocity for both the roads, so for flat road, the maximum permitted velocity is mu s rg. So mu s is the coefficient of static friction. R will be the radius of the road, and g will be the force of g will be the acceleration due to gravity. And for the banked road, the maximum permitted velocity will be rg times mu s plus tan theta by 1 minus mu s tan theta, right? And both are square rooted, right? Velocity max here will be square root of mu s rg, and here will be square root of rg times mu s plus tan theta by 1 minus mu s tan theta. Now we know that to move along a curved path, the centripetal force will be required, which will be provided by the force of friction. But we know that the friction cannot exceed its limiting value. So as we increase or we want to increase the speed of the vehicle, then greater centripetal force will be required. Now we know that as the centripetal force is provided by the friction, so and it is limited to its limiting value, so we cannot exceed or so we cannot provide greater centripetal force, right? So we cannot exceed the force of friction. So if we increase our velocity, then skidding will take place because the friction will not be able to provide the centripetal force, right? So skidding will take place. So the slope uh, helps to prevent this skidding because it provides a greater velocity. How we can know that it provides greater velocity? That here we can see that mu s plus tan theta, right? So as tan theta will be a positive value, so it will be increased by uh, or it will get or rg mu s will get increased by a tan theta, and as in denominator we have 1 minus mu s tan theta, so it will be a value less than 1, so it will further increase the velocity max. So here in this case we can know that due to banking we have a greater velocity limit, so it will not result in skidding, right? So now if we look further, that if we increase the velocity, right? So if we increase the velocity, we are required a greater coefficient of friction. So if we take that we are providing greater force of friction, so we need greater coefficient of friction. If we apply greater coefficient of friction, then it will result in more wear and tear on the tire, because eventually the force of friction is the contact force between the road and the tire. So if we increase the mu s or the coefficient of friction, then it will result in greater wear and tear. So as we know that here in the banked road, we are not requiring greater coefficient of friction for greater velocity. So with reduced coefficient of friction, we can obtain greater velocity. So hence we can conclude that for banked road, there will be a less wear and tear of the tires within the same amount of the velocity, right? Now there is another thing, that in case we are reducing the friction to 0, right? So if we can see that if we put mu s to 0, right? Mu s is the coefficient of friction. If we put it as 0, so for flat road, we can see that our velocity max comes out to be 0, right? How is it so? Because we are putting mu s to be 0, so our velocity max for flat road is 0. It means that for such condition, we cannot move our vehicle. So our vehicle will come to a standstill. We cannot move any further. But for the same condition, if we put mu(s) to be 0, we for banked road we are coming up with some velocity, which is obviously positive. So here we can see that even without friction, we can move. So how does it signify to the practical use? So in practical use, we see that when there is a reduced friction, for example, in times of rain or any other snowfall or some other condition, so there will be a reduced friction. Even if we reduce friction to be 0, then even then we have some limiting velocity by which we can move. So hence, banking also helps us to move our vehicles in times of reduced friction. Right. So I hope you understood these three conditions. That first is that it prevents skidding, then it prevents reduced wear and tear of the tire, and also it helps us to move in reduced frictional conditions. Thank you.